So we've talked already about the triangle proportional theorem. And another special case of this triangle proportional theorem, it says here it involves 3 or more parallel lines cut by 2 transversals. In this picture, lines A and B are the transversals. And notice if I extend these transversals, they intersect and they kind of form this triangle here. Actually, they form 3 triangles, and I'm going to show you. We've got the big one right here. We've got the medium-sized one, and then we've got the small size. And so all of these triangles are similar to each other because they share 2 angles. Remember, if we have parallel lines, we've got corresponding angles here, and these corresponding angles would be congruent. So they have 2 pairs of angles that are the same, which by the angle similarity property, or that makes these 3 triangles similar to each other. Keeping that in mind, it brings us to this corollary, and corollary just comes from the theorem. It's just kind of as a result of the theorem that we've talked about. As a result of this triangle proportional theorem, we have this corollary 7.1 that says that if 3 or more parallel lines are intersected by 2 transversals, then they cut the transversals proportionally. And so if this is the case, then we can say that AB is proportionate to BC, and EF is proportionate to FG. It says here, Megan is drawing a hallway in 1-point perspective, which kind of makes it look more like a 3D. If you're an artist, if you've ever drawn some pictures and you want something to look like you're literally walking down this path or make it look 3D, it's called a 1-point perspective method, I guess you could say. And she uses the guidelines shown to draw 2 windows on the left wall. If line segments AB and BC and WZ, I'm highlighting them here, WC and XY. Oh, I highlighted the wrong one here. It said AD and BC. AD, BC, WZ, and XY are parallel. Okay, so they are parallel. So I'm just going to go ahead and draw like little triangles to show that they are parallel. That's what those little arrows mean. Not triangles, but arrows. And they tell us that AB measures 8 units, 8 centimeters. DC is 9 centimeters. And ZY is 5 centimeters. Find WX. This is what we're looking for. So remember the corollary stated that if you have more than 1 parallel lines, then those parts that are being cut are also proportionate to each other. So by the corollary 7.1, if we have these, like I said, if we have these parallel lines, we can then say AB is corresponding to WX, and we can compare DC with it being proportionate to ZY. And that's what the corollary says, that those should be proportionate to each other. So now I'm going to replace the letters with the numbers that were given. So AB we know is 8. WX is what we're looking for, so I'm going to put an X because when we don't know something, we always put an X in math. DC is 9, and ZY is 5. And from here, we just take it from here with algebra. We use the butterfly method to solve. And so we would get 8 times 5 and 9 times X, which leaves me with 40 on the left-hand side, and 9x here. If we're going to solve this by hand, we can divide both sides by 9 to get x by itself. This reduces to 1, and 40 divided by 9 gives me 4.4, and this is in centimeters, so we're going to put centimeters, and that leaves me with x. And this is my final answer. And x, what we're looking for, instead of saying it's equal to x, we can replace this back to wx. That's what we were looking for. So the length of line segment wx is 4.4 centimeters. And we did this by using the corollary 7.1, which says that if you have several lines parallel being cut by two transversals, it cuts it in proportional ways, and we matched the corresponding parts, wrote the proportion, and solved for our missing side. I hope that made sense.